Okay, here's another problem. A car is initially at 8, -10 and traveling at 52 miles per hour in the direction of 12i plus 5j. Find the position vector of the car if you are standing at point 0, 0. Try to hit the pause button and work this out on your own. Now, a couple of things you should be aware of. First of all, it says the direction of the vehicle is 12i plus 5j. See, that is not the velocity vector. It is my directional vector. Right here it says the speed of the car is 52 miles per hour. This is my speed. The car is initially at 8:10 and we are standing at the point 0, 0. The first thing I need to compute is my velocity vector using the given information. The given information was that the directional vector is 12i plus 5j. So I'm just going to call that d for directional vector. Now it says the speed is 52 miles an hour. If you recall, the speed is the magnitude of your velocity. Now, according to a couple of problems we had, the directional vector is parallel to the velocity vector. And the definition states that there exists some constant, we don't know, that's what we're going to look for, such that that constant times vector d is equal to vector v. Now, using the basic principles of substitution, the d vector is 12, 5. And the velocity vector we don't know, so we give that variable names, x and y. Now, one thing I do know is that because I don't know what x and y is, I can't find its, I can't use it. But I do know that its magnitude is 52. So that means that k times the magnitude of d is going to equal to 52. Remember, magnitude is done in absolute value. Giving myself a little bit more room here. K is going to equal to, I'm just going to use Pythagorean theorem again, 12 squared plus 5 squared. Not k is going to equal to, but k times 12 squared plus 5 squared is 52. Simplifying this, k times 144 plus 25 equals 52. Or k times the square root of 169 equals 52. Or 13k is equal to 52. Giving myself some more room and simplifying this problem, divide this by k and by 13, and dividing this by 13, k is going to equal to 52 divided by 13, which is 4. So now I know what k is. K is 4. Now if I scroll all the way back up here to my work, I'll do it all the way. If k is 4, I could plug it into this equation right here. K equal to 12, 5. K times 12, 5 is equal to x, y. Plug it in for k. 4 times 12, 5 will equal my velocity vector. 4 times 12, 4 times 5. Distributing the 4. Remember, this is my velocity vector. You can see it right there. 48 times 20 is equal to my velocity vector. Need this. Okay, now that I found my velocity vector, it's now time for me to compute the other portion of my problem, the position vector. And I'm going to draw a little picture. Unfortunately, there is no way I could fit 48 and 20 units on my graph, so I'm going to have to fake it a little bit. If we start here at 8 comma 10, negative 10, and we travel in a velocity of 48, call that point right there, 4820. That means that that position vector will be from me to wherever the car is at any given time will equal to AB plus my velocity vector will equal to AC. So the position vector AC will equal to the vector from me to where I first spot the vehicle plus the velocity of the vehicle times t. Using the same equations, first going to set this up in component form. AC will be the x component and the y component, and that will equal to x2 minus x1. Remember, this is 0, 0, so this is going to be x2, x1. 8 minus 0. y2 minus y1 for the component vector, negative 10 minus 0, plus my velocity vector. Well, the velocity vector I found to be 48, 20, t. Simplifying this, xy is equal to 8 negative 10 plus 48t 20t. Now I could combine this all together, or I could leave my answer just like that. xy is equal to 8 plus 48t negative 10 20t. And here I have my position vector. Now, more than likely, the problem isn't going to end here. It's going to probably ask you to find what will be the position of the car after 1 hour or 2 hours, 3 hours, maybe a set of hours. When will the car be directly east of us? I have about 2 minutes. I think I could actually solve that. When will the car be directly east of us? Well, let's see. In other words, if I'm finding directly east of us, I am looking for this vector right here. When will the car be right there? So the first thing I have to do is I have to write this equation in parametric form. The parametric form of the equation is the x component makes up one equation and the y component makes up another equation. Now, if I look at the picture directly east of us, let's see, I go up and down 0, and how far right is the car? I don't know. So up and down is y. That means that y is 0. Left and right, I have no idea. Left and right, I have no idea. Can't solve this because I don't know what x is. And that gives me 0 is equal to negative 10 plus 20t. Add 10 to both sides. 10 is equal to 20t. Divide both sides by 20. T equals a half. So in a half hour, the car will be directly east of us. I hope this is useful. Please email me any questions.